So in last video, we calculated magnetic field due to a circular ring, due to a current carrying circular coil or ring at its axis, at center, at surface. Now today in this video, I'm going to find magnetic field due to a straight current carrying conductor. So as you can see, there's a straight conductor in which I current is flowing, and let me mark a point P at which electric field has to be calculated by because of this conductor. So P is the point at which electric field is to be calculated. Now let us say the value of R, value of OP, the distance from O to P is R. Fine. Now we have to do some construction. First of all, what you do, you have to mark or that length element. If you remember Biot Savart Law, it talks about that length element in which current is flowing, according to which magnetic field is mu naught by 4 pi I dl sine theta by r square. So I am marking this much as dl. I am taking a quite a large length just for your convenience so that you can understand it well. But in actually or in practice, this length is very small. dl is very small. Now what you do, you join this P point from both ends of dl. Okay. Now let this angle be theta. Let this angle be theta. And this would be a very small angle. Let this be d theta. Fine. If this is 90, this angle would be 90 minus theta. Let the distance of this point from this point be from till P should be x. You can mark, let this be A point and let this be B point. Fine. Now as I told you that this A and B point would be very close to each other. They won't be very far away. So if this is 90 minus theta, this angle would also be approximately equal to 90 minus theta. Why? Because A and B points are very close to each other. So this angle would approximately be equal to 90 minus theta. So this is a diagram in which you have to make one more construction. You have to draw a perpendicular. You have to draw a perpendicular from A to N. Let this be N, and you have drawn this perpendicular here. And this is perpendicular by construction. So this is a diagram that I'm going to use to solve the magnetic field due to a straight current carrying conductor at this point P. Now I'm using Biot Savart law, that is B is equal to mu naught 4 pi I dl sine theta. Now theta here is 90 minus theta. So I will write I dl sine 90 minus theta divided by r square. Distance is x. From P point to that length element is x. So it becomes x square. We know sine 90 minus theta is cos theta. So this can be written as B is equal to mu naught 4 pi I dl cos theta by x square. So as because of this length element, it won't be total magnetic field. This would be a small magnetic field, that is dB. So dB is equal to mu naught 4 pi I dl cos theta by x square. Let this be your equation number 1. Now, if you consider triangle A and B, if you consider triangle A and B, if I use formula sine 90 minus theta, if in triangle A and B, I'm using sine 90 minus theta. Sine is perpendicular divided by hypotenuse. So in this triangle, perpendicular is AN and hypotenuse is AB. AN divided by AB. Value of AB is DL. AB length is equal to DL. So the value of AN would be DL cos theta. Let this be your second equation. Okay. Now, if you see one more triangle, that is A and P. In triangle A and P, I'm using triangle A and P. See triangle A and P. If I again use sine, that's sine d theta. If I use sine d theta, sine again would be perpendicular divided by hypotenuse. So perpendicular would be AN and AP would be hypotenuse. Now this step you have to remember. See, d theta would be very small. So sine d theta can be written as equivalent to d theta. So AN would be AP d theta and value of AP is X. So value of AN can be written as X into d theta. Value of AN can be written as X into d theta. This step is after this step, right? AN by AP, AN is equal to AP d theta. Sin d theta becomes d theta because d theta is a very small angle. So let this be your third equation. Now if you compare second and third, you get the value of dl cos theta to be equal to x d theta. From second and third, what you get? Value of dl cos theta is equal to x d theta. Now let this be your fourth equation. Now if you substitute this value in first, if you put fourth equation in first, you can substitute dl cos theta by x d theta, right? So you can write db is equal to mu naught 4 pi idl. I would be using x d theta because dl cos theta is equal to x d theta divided by x square. Now 1x would cancel out and the value which you will get is db is equal to mu naught 4 pi I d theta by x. Let this be your equation number 5. Now if you see triangle AOP, if you see this triangle AOP, so in triangle AOP, if I use cos theta, cos is based by hypotenuse. So in triangle AOP, cos theta angles theta, base is OP by hypotenuse, that is AP. So R divided by X. Cos theta would be equal to R divided by X. So you can find value of X that can be written as R divided by cos theta. So you can write X is equal to R divided by cos theta. You can substitute this value in this equation. And when you substitute this value in this equation, what you will get? You will get dB is equal to mu naught dB is equal to mu naught I 4 pi mu naught I 4 pi d theta by x. X can be written as r by cos theta. So it becomes cos theta d theta by r. Now you want to find magnetic field. So for finding magnetic field, what you need to do, you need to integrate this, because integration of dB would give you B. So if I integrate, you want to integrate this, right? So we have certain cases before doing integration. The first case is if the conductor is finite, right? The length is finite. Or what you can do before starting case, you can simply put the limits. See, if you integrate this, what you will be getting, we know integration of cos theta is sine theta, and theta would be ranging from theta 1 to theta 2. So I'm writing it again, cos theta d theta by r. Now for finding b, what you need to do, you need to integrate this, right? dB is equal to integration mu naught I 4 pi cos theta d theta by r. So constant terms can be taken out. B is equal to mu naught I divided by 4 pi r. Cos theta becomes sin theta, and limits can be taken from theta 1 to theta 2, initial to final. So mu naught I by 4 pi r. If you put value, it would be sin theta, theta 1 to theta 2. So on doing integration, you get sin theta, theta 1 to theta 2, and upper limit minus lower limit. That is mu naught I 4 pi r sin theta 2 minus sin theta 1. Now for the first case, that is finite. If conductor is finite, what you need to do, you need to put value of theta 1 and theta 2. Now if you see this, let us say this is a finite conductor. If you also join this point, this would be your first theta, theta 1, or in some books it can be written as phi 1, and this would be your second angle. This can be written as phi 2. So for the case of finite conductor, theta 1 can be replaced by phi 1, and theta 2 is to be taken as phi 2. But by convention, one of the angles has to be taken as negative, right? So you can take theta 1 as minus theta 1 and theta 2 as phi 2. Now if you put value in that formula, what you get? You get mu naught I 4 pi r sine phi 1 plus sine phi 2. So this is the formula for finite conductor. So in any numerical you get of conductor and its length is finite, you will use this formula. But for infinite conductor, in the case of infinite conductor, you just have to think the value of phi 1 and phi 2. Now if you see diagram again, in case of infinite conductor, what can be the maximum value of infinite would be somewhere here, and this, as the length would increase, this angle would increase. The maximum angle this can be pi by 2. So phi 1 can become pi by 2, and for this length, if this is infinite, this length also increase, and it can maximum go to pi by 2. It can maximum go to pi by 2. So phi 2 would be also pi by 2. Both will be pi by 2. So if you put pi by 2 and pi by 2, so sine 90 plus sine 90. Sine 90 is 1. So 1 plus 1 is 2. This 2 cancels out this 4 by 2. So the formula for B for infinite conductor would be mu naught I divided by 2 pi r. And the reason for this is phi 1 and phi 2 would be 90 degree for infinite conductor. So for numericals, for finite conductor, you would be using this formula, and for infinite conductor, you would be using this formula.